Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai. Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia dengan hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Umul Kitab Al-Fatihah. And for the non-Muslim, please recite your prayers according to your religion. Okay, so how is everyone doing today? My prayer that everyone is in the best of health and are ready to proceed with today's class. Let me introduce myself first. I am Madam Rosmaya as your moderator for today. I am a Form 6 Physics teacher at SMJK Yuhua, Kajang, Selangor. And together with us is Teacher Im, okay, our host controller. Okay, her job is to ensure the smoothness of our lesson on technical support. She is from College Tingkatan 6 Tapah Perak. And our observer, Teacher Naini, okay, from Pusat Tingkatan 6 SMK Sultan Sulaiman, Kuala Terengganu. And the most important person today is our presenter, Teacher Zainariah. She is a very experienced retired teacher from SMK Tengku Ampuan Durrah Negeri Sembilan. So let us give a warm welcome to our presenter.
Thank you.
Okay, for the record, we are now live on Teacher Zainariah channel. So as a sign of support to Teacher Zainariah for the hard work in preparing today's lesson, please subscribe her channel. Not forgetting also to Teacher Im and Teacher Naini channel too. Okay, as usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use email, e-didik email to claim the certificate. So for credit claim, you need to collect the 1 letter and 4-digit codes, which will be announced separately at certain time during our session, during the class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture, if possible your own page, if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused, and if you have any questions, please write on the chat box and Teacher Zainariah will try to provide you with the answers. So without further ado, before that, I want to, I would like to announce the first digit code before I give the to Teacher Zainariah. So the first digit code to claim for credit claim is A3. Okay, letter A and number digit 3. Okay, so without further ado, please welcome Teacher Zainariah to start her presentation.
Okay. Good evening, everyone. Thank you for joining to my class. And I would like to thank also to the 3 teachers who are accompanying me today. Without them, okay, they are the most important person because they have to ensure that the class will run smoothly. Okay, now, right, as we see here, I'm sharing my slide, okay. I'm already a retired teacher. My previous school is from START, short form, from Negeri Sembilan, and this is my YouTube channel, okay. Right, I would like to share some information, okay, that we have prepared a playlist for the online classes for SEM 1, SEM 2, SEM 3 Also, we have a playlist on the video lesson for all the 3 semesters. Okay, and also we have a playlist on video lesson from the pre-U lesson collaboration, which consists of chemistry, okay, which is head by Cikgu Shanun, okay, the head of the chemistry panel. And then we have biology, head by Cikgu Faiza, and we have Cikgu Naini, one of the teachers here, okay, Cikgu Naini here wearing the brown or beige scarf. And we have the physics, okay, we have Cikgu Rusmaya, our moderator today. And also we have the economy and perkawanan lesson. And last but not least, the mathematics video lesson collection. Okay, so where to get the link for this playlist? Okay, if you go to my video, beneath it, okay, there's a video description right at the end. Okay, there are some link to the playlist, but I am sharing only the pre-U lesson collaboration, number 1. Number 2 is Stpm, PERCUMA and others playlist, our semester 1, and for the video lesson, and semester 1, the past life class, okay? For semester 2, you have to check out during our semester 2 classes, okay? Right. Let's look, what are we going to learn today? Okay, we're going to look at functions. Function is the first chapter for the semester 1, okay? So for the semester 1 student, take this, I know that you have done this, so take this as a revision, and also for the semester 2, take this as a revision class. So all of us have know that function is a relation from a set of input to a set of output, but each input is related to only exactly one output. So today we're going to learn in detail what is domain and range of function and how to find the domain and range of the functions. Okay, let's go. Let's start. Okay, now consider the function that maps x to y, okay? So what is domain? The domain of the function is a set of all possible values of x for which f is defined. In other words, domain refers to the set of possible inputs values. Remember just now I mentioned inputs. So what is range? Range is the set of possible y values or f of x that the function takes. Okay, in short, or simple way of saying the range is the set of possible output values. Okay, right, now let's look at more example on the domain of function. Now consider these two functions g and h defined as, okay, function g maps to x cubed, x maps to x cubed for all x in R, h such that x maps to x cubed for all x in R plus. Okay, now they look the same, okay, they look similar, but they are not the same. So it's why? Because if you look here at the end of function g, we have x in R, which is the domain of g, and x in R plus, and behind h, there is domain of h. So both of these are called the input values. Okay, notice that the domain must be indicated for a function to be completely defined. The two functions are not the same because their domains are different. Why? Because here h is restricted to all positive real numbers, that is x greater than 0. So it's important, class, that you must indicate the domain, okay, the input values. Right now, so what is range? Okay, again, refer to the same function, g, such that x maps to x cubed for all x in R. So we refer back to the domain x equal x in R. So to find the range, we calculate x as x cubed. Now x cubed is also for all x in R. Okay, it takes any value in R. So the range of g is also for all values in R. We can use the symbol gx here, or you can use y in R, or you can simply write R. Or if you prefer, you can write in interval notation form, from negative infinity to infinity. Okay, so choose one method of writing, either using the set builder notation or the interval notation. Okay, now let's look at function age. So the domain is for all x. Okay, for all x are positive, what does it mean? It means that for all x greater than 0. So find the range, that is h of x. It is still x of q, but because of the domain, the value must be greater than 0. So the range of h is h of x such that it's greater than 0, or you can simply write y greater than 0, or in interval form from 0 to infinity. Okay, remember for interval notation, the round bracket means it's not inclusive. Okay, so this is the range of functions. Now, what about the graph of these two functions? Clearly, they are not the same. Why are they not the same? Because the domains are not the same. Okay, but from the graph of the functions, we can state, okay, the domain and the range. Okay, so the domain of G, notice that here we have the arrow, yellow arrow indicates that it is defined for all x in R, and here the yellow arrow indicates that the range is defined for all x in R too. Okay, the range is also for all y in R. For all y in R. Okay, so from the graph you can tell the domain and the range. But for the function h, notice that our domain starts from, here the interval notation, I forgot. Okay, for the function h, notice that x equals 0 is not included because here this is an open dot. Okay, so the domain of h is for all x in R plus or x greater than 0. And the range, notice that the range starts from 0 onwards, but 0 is not included. Okay, so you can write as y greater than 0 or from 0 to infinity. So you see here we have the graphical method to determine the domain and range. So how to find the domain and range? Okay, consider the graph y equal f of x, which is defined for all x between a and b, where the respective y values is c and d. So the domain starts from x equal a to x equal b. Okay, and the range extend. Okay, sorry, I would like to highlight here because of this equal sign, because of the closed dots. Okay, so it's equal less than, x greater equal a, b greater equal x. Okay, here square bracket to show that because of the closed dots. So the range, okay, starts from c, extend to d. So we write as range in interval form CD square bracket because C and D are inclusive, or you write down C less than equal Y less than equal D. So this is how we use the graphical method to identify the domain and range. Similarly, we can use the algebraically method to find the domain and range. Okay, now please take note of the basic function with domain restriction. Altogether, we have 3 domain restriction. For basic function, I'm talking about basic function. Okay, the first one is the square root function. Okay, sometimes it's called the radical function. So the value below the radical is called the radicand. It must always be greater equal 0. For square root function, okay, the index is even. Then we have the reciprocal function, the denominator cannot be 0. And next we have the logarithmic function, where the logarithmic of a value x must be greater than 0. It must be positive. Okay, this is for basic function. Okay, we can apply this for more complex function. Okay, let's look at the examples given in the notes. Okay, the first one, we have a polynomial function. It looks like it's a quadratic function, which is a polynomial function and is of degree 2. Okay, And we notice that it is defined for all x in R. We can plug in any value of x, we have a value. So f is defined for all x in R. So how do you write down? We write down either using set notation or just symbol R, or using the interval form. Now, to find the range, we look at the domain. Okay, since the function is an even function, polynomial function with even degree, and the leading coefficient is -2, thus the range, to find the range, you have to find the vertex. The vertex here is a maximum point because of the leading coefficient is negative. Okay, so we call it the vertex. So the range is for all for all f of x less than equals 7, or from -infinity to 7. We say that the range is bounded from below till the maximum y min. Okay. Next, okay, we can use the graphical method to identify the domain and range. Okay, of course, using graphical method, you have to sketch the graph. Okay, this is quadratic with maximum curve. The maximum point is -1,7 and it cuts the y-axis at 0,7. Clearly, we can tell that the domain extends from -infinity to infinity. I prefer using interval because here we know that it comes from -infinity to infinity. But remember, okay, the graphs is beyond, is extend to wider portion of the graph. This is what we see, visibly see in the graph. So now the range is bounded from below, okay, -infinity to y maximum 7. Okay, that's how we use the graphical method. So it's easier to use graphical method compared to algebraic method. Okay, next function, we have, this one is not given, but this is just a matter of discussion. We still have a polynomial function, but of degree 3, meaning that this is an odd degree. So if a polynomial is of an odd degree, so the domain is still for all x in R. Okay, this is the interval form. And what about the range? The range is also for all y in R. Okay, this can be seen from its graph. Okay, this is the graph of the cubic function. So notice that domain comes from -infinity to infinity, and the range comes from below -infinity until upwards. Here we cannot see. Okay, it goes continuously upward. It's beyond our visible eye. Okay, so here we can make a conclusion if you look at my notes. Okay, all polynomials have the same domain. No matter whether it has an even or odd degree. But for even degree, the range, okay, you must look at the negative. You have to look at the leading coefficient. If it is negative, so it's from -infinity to y max. That's what I've been showing you. If it's positive, the leading coefficient is from y min going downwards to infinity. Going upwards. Y min going upwards to positive infinity. So negative leading coefficient equals upward, positive leading coefficient equals downward. Okay, but if you have an odd degree, the range is simple, it belongs in R, or from -infinity to infinity. Okay, right. So that is about polynomial function. Now, B, this is a square root function, or you can say a radical function with index even, with an even index. Okay, n is 2. So we know that for a radical function or square root function, the radicand cannot be negative. So f is defined for all x minus 4 greater equal 0. This is the condition. I don't know where's my mouse. Okay, x minus 4 greater equal 0. So f is defined for all x greater equal 4. So writing in set interval form, we have this. Writing in interval form, we have this, okay? For all x greater equal 4 to infinity, okay? Here, the symbol says 4 is inclusive. Now, to get the range using algebraically method. So we start from the domain. Okay, we know that x minus 4 is greater equal 0. So find the square root of x minus 4 is still greater equal 0. So what is square root x minus 4? The function f of x, which is greater equal 0. Thus, our range is for all, the range is f of x such that f of, I don't know why it's going very fast. Yeah. Okay, the range is for f of x such that f of x is greater equal 0, or in interval form from 0 to infinity. Okay, so this is using the algebraic method. Okay, so to use the algebraic method, you must know the characteristic of the function. Okay, now this is the graphical method, graphing the square root function. Okay, now I'll start with the basic radical function. We have y equals set x. Okay, notice that here is minus 4. What does minus 4 means? Okay, notice that here I have a closed dot to show that 0 is inclusive. Right, minus 4 means we translate, okay, or the graph undergoes a translation 4 units to the right. Okay, your teacher must have taught you using transformation. Okay, we have 4 units to the right. So here the point 4, 0. So from the graph, we can tell the domain starts from 4 till infinity, and the range starts from 0 to infinity. Okay, so for the range, you always look at the curve, 0 to finite value. Okay, so I would prefer, some students prefer the set notation form. Sebab senang, they say, I can see this is x, teacher, I can see this is y, so I'm not confused. But interval form, I have to state the domain f, the range f, or else I get confused. So up to you, okay, which notation you are comfortable with. Okay, next we look at, okay, this is another discussion. We have a cube root function, just now square root function. Now, can anybody guess what is the domain of f? This is cube root. The index is odd. Just now for root function, when n is even, the radicand cannot be 0, it must be greater equal 0. But this is cube root, hence the domain must be all x in R. Okay, tak apa. Right. And the range is also for all y in R. Okay, let's see the graph whether it's correctly stated. This is the graph of the cube root x minus 8. The graph is being shifted 8 units to the right. Okay, if x cubed, the point here is 0. So notice that the domain starts from negative infinity to infinity, but the range, okay, starts from negative infinity to positive infinity. So we can make a conclusion here. If n is even, okay, to find the domain, the radicand must be greater equal 0. But when n is odd, the domain is for all x in R. Okay, the range, you have to refer back to the domain, okay. Normally, when for simple radical function for n even, it's always y greater equal 0. Okay, it's always greater y. It's always y greater equal 0. But for n odd, is for all y in R. Okay, f of x in R. Okay, here we have a reciprocal function. Okay, we know it's a reciprocal, it's 1 over x plus 2. So, as I mentioned earlier, the denominator cannot be 0. So, f is not defined if x equal negative 2. Remember, f is not defined if x equal negative 2. So, for the function f to be defined, the domain should be for all x in R, x cannot be negative 2. It's easier in set notation form compared to interval because we break up at negative 2. From negative infinity to negative 2 or from negative 2 to infinity, we have to break up. Okay, next, to find the range, okay, here the fraction can never be equal 0. Why? Because for all x tends approaching infinity, meaning that x getting bigger and bigger, 1 over x plus 2 will approaching 0. Thus, the range of f is for all f of x in R, but f of x cannot be 0. Okay, or here in interval form, negative infinity to 0 or 0 to infinity. Dia auto because saya slow nak tekan. Okay, negative infinity to 0 or 0 to infinity. Remember, fraction here cannot be equal 0. Okay, now graphing the reciprocal graph. Okay, remember the reciprocal function, the basic reciprocal function is an arc in the first and third quadrant with the asymptote x equals 0, y equals 0. Ya, dia cepat sangat. Okay, so now we translate 2 unit to the left because this is plus 2. Okay, so the asymptote is being translated 2 unit to the left, x equal 2, and the asymptote y equals 0 remain the same. So now translate the curve. Okay, so we have y equal 1 over x plus 2. Okay, can you determine the domain? Already mentioned just now. Okay, okay, Darwin, you can see the name Darwin there. Okay, so the domain is for all x in R. Remember the asymptote is x negative 2, y equals 0. So for all x in R, x cannot be. There's a typo error here, x negative 2, okay? So domain is for all x in R, x cannot be negative 2. So notice that here there's a circle to show that it breaks. The curve breaks at x negative 2. Similarly for range, okay, the value breaks at y equals 0. So in other words, if you have reciprocal function, you must always identify the asymptote because at the asymptote, the curve breaks. Okay, the curve breaks at the asymptote. Okay, the curve breaks at the asymptotes. Okay. All right. Okay.
Teacher Zainariah, would you like to take a break now and let the students to absorb all the informations given just now?
Okay. All right. Okay. All right.
Okay, so before we take a break with the advertisement, later I will announce the second digit code, okay, for the credit claim. Okay, so the digit is number 1. Okay, the digit is number 1. Okay.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay.
Thank you, Madam Usmaya. Right. Okay, I have to be fast. Okay, this is a rational function. Okay, the difference between rational function and reciprocal function. For rational function, the numerator is a polynomial function. Okay, that's the difference between rational and reciprocal. Again, the denominator cannot be 0. So f is defined for all x such that x cannot be 4. Okay, sama, is the same. And the range, okay, now because this is rational, you have to find the asymptote. So I rewrite this function in different form, -1 plus 6 over 4 minus x. There's an easier way of identifying the vertical asymptote. X here divided by -x is -1. So, sorry, the horizontal asymptote. X divided by negative x, we have negative 1. So meaning that this fraction here, rational function here cannot be negative 1. Okay, no matter what you plug in, it cannot be negative 1. Okay, as we know, as x tends to infinity, the fraction here tends to 0, hence negative 1 here plus this fraction will tend to negative 1. So our range will be for all x in R, f of x cannot be negative 1. Or in interval form, okay, you have to write in this form. Notice that it breaks at negative 1. Okay, so let's look at graphing method. Okay, we have the two asymptotes. Okay, here we cannot use transformation. You have to sketch from scratch. Okay, so do the asymptote just now. We have x equal 4, y equal 1. Now, to identify which quadrant does the curve lies, okay, notice that you have to find the x and y intercept. When x is 0, okay, we have y as half, and y is 0, we have x negative 2. Thus, the arc passes through the points, the x-intercept and the y-intercept. So the other arc will be the symmetrical at the point, at this point of intersection. Okay, so this is the graph of the rational function. Okay, notice that the domain, okay, lies for all x in R except for x equal 4. Here there's a break, okay, and the range, okay, from below for all y in R, there's a break here except y equals negative 1. Okay, so this is how we identify the domain and range for rational function. Okay, next for ln. Okay, ln, we know that the value here must be positive. Thus, h is defined if x minus 2 greater than 0. In other words, for all x greater than 2. So domain of h is for all x greater than 2. Now, to find the range from the domain, x minus 2 is greater than 0. So when we take ln, be careful, is equal 0 when x is 3 and greater than 0 when x is greater than 3. But ln is negative for all value of x between 2 and 3. If you don't believe me, you plug out any value here, 2.5, we have a fraction. Okay, ln of a fraction is always negative. Thus, h of x is greater equal 0 for all x greater equal 3, and h of x is less than 0 for x between 2 and 3. So how do we write this? So the range of h is for all x, for all h of x in R, or for all y in R. Okay, let's do the graph. Okay, we have start from basic ln x. So minus 2 means you translate everything 2 units to the right. So translate first the asymptote, x equals 0 to x equal 2, and you translate, okay, the curve ln x. So you have y equal h of x. Clearly, this is the domain, okay, from x equal 2 onwards, and this is the range, okay, from negative infinity to positive infinity. Okay, so graphing is easier compared to algebraically method. Okay, now here we have exponential function. We know that e to the power of x or e to the power of negative x is defined for all x in R. Thus, there's no value of x for h not to be defined. So h is defined for all x in R. Okay, and then from the domain, okay, as x tends to negative infinity, what happened here? Okay, it tends to positive infinity. Hence, your h of x tends to negative infinity going down, okay? When x tends to positive infinity, our h of x tends to 2 or approaching 2. So in other words, your h of x goes from bottom till 2. So h of x is less than 2, okay, from negative infinity to 2. So the range of h is from negative infinity to 2, or you write down as h of x less than 2, okay? Okay, graphically, okay, we start with the graph. Okay, this is asymptote y equals 0. Okay, we have 3 times e to the power of x to save time, okay? Now we have negative here. What does it mean? It means reflection about the y-axis or horizontal reflection. Okay, then we have negative here. What does it mean? We reflect about the x-axis, vertical reflection. And then we have 2, we translate 2 units above. So translate the asymptote first, then translate the curve. So from the curve, we can tell that domain is for all x in R, and the range is for all y in R, and y must be less than 2. Okay, h of x must be less than 2, right? Okay, now I'm purposely giving you trigonometric function because you have done this in Form 5 just to help you to trigger back your memory on the transformation of the graph. Okay, remember, okay, so first we look here, this function is defined for all x in R, okay? And to get the range algebraically, we start from sin x must lie between -1 and 1. Look at the sine curve, it's between -1 and 1. So we times 2, okay, both sides with times 2, and we add 1. So we have f of x between -1 and 3. So this is the range, okay? Y lies between -1 and 3. Okay. So remember the sine x curve is continuous, yes, students. That's why cikgu buat as many as possible. It's beyond the graph as that we see. And times 2 means the magnitude increases to 2 units. Plus 1 means we translate the graph 1 unit upwards. So from here, clearly the domain is for all x in R, but the range, okay, notice that it's from -1 to 3. Okay, so to do graphical method, you must know the nature of the function, okay? Okay, now we have this models function. Again, to find the domain and range, we have to consider expression by expression. We look first the modulus of x plus 2 because we need to open up the modulus. So this is the definition. Next, modulus x, this is the definition, okay? But this is clearly understood if you were to sketch the graph, okay? Notice that for all x greater equal -2, that's why it's positive x plus 2. For all x less than -2, that's why it's negative x minus 2. Similarly, for here, modulus x, for all x greater equal 0 is positive x. For all x less than 0, this is negative x. Okay, now to summarize this, we divide the graph into 3 regions, okay? Hang on. We divide the graph into 3 regions, okay? 1, 2, 3. So the first region is for all x less than -2. So look at the function for all x less than -2. We have minus x minus 2 and minus x. We have -2, okay? And then between, from x -2 to 0. So from -2 to 0, we have positive, look at the line, positive x plus 2 and negative x. So we have 2x plus 2. And next, the third region for all x greater equal 0. Okay, look at the line. We have positive x plus positive x plus 2. Okay, so we have x plus 2 minus x, which is 2. So when we open up this modulus, notice that we have a piecewise function. Okay. So why it's called piecewise? Because the graph will be drawn piece by piece. But looking at the summarized or simplified expression of the function gx, we can tell the domain is for all x in R, okay? Less than -2, so from -infinity to +infinity. And then from the range, we can tell from the function from -2 to 2. Or you can do the graph. Okay, we start from x less than -2 is just a horizontal line parallel to the x-axis. And then from -2 to 0, okay, substitute -2. Okay, you have -2, substitute x is 0, you have 2. Okay, and for all x greater 0 is also a horizontal line parallel to the x-axis. So again, the domain is for all x in R, and the range is from -2 to 2. Okay, so it's easier to use graphical method. Okay, now this is quiz time. I already given you the question. So can anybody state which is the correct answer?
It is time to announce the third digit code.
Okay, right. The third digit code, please.
Okay. So the third digit code, okay, for credit claim is number 1. Okay, number 1. Okay, Teacher Zana can
Kenapa?
continue.
Ya, dia
Too
I'm not
fast.
using this computer. Okay. So, anybody can guess? If you saw just now, the answer is B, okay? The answer is B. The computer is showing me the answer. The answer is B. Okay, let's see whether it's correctly chosen B. Okay, we know that G is defined. The radicand must be greater equal 0. So we have to factorize it, and we use the number line method to find the range of values of x that satisfy the inequality. Remember how to use the number line method. So we have to assume that the factors are positive. Okay, so this is x greater equal 3. This is x less than equal 7. Be careful, students, okay? So we want the region whereby it gives you greater equal 0. So this is the region plus. So domain is for all x in R for x between 3 and 7, okay? Using algebraic method. Or you can use the interval form here. Okay, next. Anybody got the answer already? Okay, tak apa. The computer is very fast. While I didn't show it's auto, but then there's a new format, Windows 365. If you are slow, they will join the prayer. Okay. Okay, so we have 3 answer here, which is correctly stated. Anybody? Is it A? Is it B? Is it C? So clearly, x cannot be equal to -3, right? Because ln cannot be 0. Hence, it must be B. Okay, let's look. So f is defined. It must satisfy these 2 conditions. The first condition is for this term, 2 to the power -x. It's defined for all x in R. But for ln, x plus 3 must be greater than 0. In other words, x must be greater than -3. So doing the number line to find the region that satisfy these 2 conditions, x in R or x greater than -3. So we do the line. This is x in R. This is x greater than -3. So this is the region. So this is correctly chosen. X greater than -3 for all x in R. Okay, C. So using the 2, okay, this is the answer. Okay, because we are running out of time. So for M to be defined, the top part, x plus 2, must always be greater equal 0. And the denominator cannot be equal 0. Remember the condition, okay, the restriction. So here, x must be greater equal -2. Here, x cannot be -4 or x cannot be 4. Okay, now again, find the values of x that satisfy these 2 conditions. So do the number line. Okay, the first one represent x greater equal -2. The second line represent for all x in R, x cannot be -4, x cannot be 4. So see where the region intersect, overlap. Okay, so they overlap at x greater equal -2 and x cannot be 4 for all x in R. Okay, last one. Or this is the interval notation form. Okay, last one, D. Oh, my A is missing. Okay, it's A, y, x cannot be -4, x must be less than -3 or x greater than 3, okay? Okay, now, for n to be defined, okay, the top part, x squared minus 9 must be greater than 0, okay, ln, remember? And the bottom denominator, okay, cikgu factorize first. And then I use the number line to find the value of x that satisfy the inequality. This is form 5 method. So straight away, this is the region that satisfy the inequality. That is x less than -3 or x greater than 3. And it must also satisfy the condition that x plus 4 cannot be 0. That is, x cannot be -4. But again, we need to find the values of x that satisfy these two conditions. Okay, so this is for all x in R, x cannot be -4. Okay, see where does these three lines or this region overlaps. Not line, yeah? The region overlap. This is x less than -3, x greater than 3. So it overlaps here. Okay. Hence, the domain is for all x in R, x cannot be -4, x must be less than -3 or x greater than 3. Okay. Or if we use interval notation, it's quite tedious because we break at -4. Dia marah kat saya because I'm slow. Okay, tak apa. So number 3, can you just state the domain for me? Just state the domain using interval form. Anybody? Okay, it's already given here. Sekejap. Can everybody state the domain for me? Okay, notice that here, okay, we have a shaded dot, meaning that the points are inclusive. Okay, so we don't have to go beyond the graph because we have a closed dot here. So what is the domain? Can everybody guess? Can anybody guess? Yes. Okay, tak apa. Can everybody guess what is the domain? Because we have here, okay, never mind, I'll give you the answer. Okay, the domain x starts from -2 because we start from -2 until 4. Okay, I prefer the interval notation. Okay, thank you, Adam Nasir. You are right, well done. And the range, okay, and the range, notice that -2 is inclusive till 16. Okay, so the range is -20 to 16. Okay, thank you, Adam. All right. Can we try now? B. Okay, notice that this is a root function. I mentioned just now, for root function, is always the range is always y greater than equal 0. But notice that here the y is below 0, below the x-axis. Okay, why? Because the function here, the root function here, has a negative sign in front. Negative sign means, okay, negative sign means it reflects the curve about the x-axis. It is a vertical reflection, okay, because of a negative sign. So remember, it's the basic function that I stated in my notes. Okay, can everybody write the domain here? Okay, notice that here, the dots, this is unshaded. So meaning that the point is not inclusive, but here the point is included. So domain, anybody? Before the computer give me the answer. Anybody? Okay, straightly. Okay, the domain, notice that here the green arrow is -3 to 5, okay? It's from -3 to 5, okay? Because here is unshaded because -3 is not included, okay? And the range starts from -4 extend to 0. 0 is included because the point is inclusive. So be careful of the round bracket and square bracket. Round bracket means it's non-inclusive, square bracket means it's inclusive. Okay, it's just matter of identifying. Okay, use the graph that are given in the notes, identify the domain and the range. Okay, now C, can you try C? This is, it looks like a reciprocal function, but the denominator is 1 minus x squared. So because of this x squared, you have two asymptotes, two vertical asymptote, -1 and 1. I don't know why it's going auto. It's not auto actually, but this computer there. Okay, right. So here, of course, y cannot be 0. Okay, this is not the basic function, okay, 1 over ax plus b. We have x squared here. So domain, anybody wants to try? Domain is very easy. It's for all x in R except what? It breaks at x -1 and x equal 1. Oh, Chan Kwan, thank you just now. Adam pun, I didn't notice your comment. Thank you very much. Okay, right now for C, can everybody try? I think my internet is slow. The answer is coming out quite late, okay? Okay, never mind. Okay, negative infinity to -1. That's right, Chan Kwan. You are very, very correct. Bagus. Well done. Okay, so it's quite tedious to write down the interval form, okay, but Muhammad Shafiq, but we have to break, okay, it breaks at x -1 and x1, yeah, domain. It breaks at x -1 and x1. From the curve, you can tell it breaks. Okay, Chan Kwan did it correctly. Okay, congrats. Okay, what about the range? Anybody want to try? The curve breaks, okay? So you have to say it cannot be -1. Okay. Here we have two range. Okay, one is from 0 to infinity. Okay, round bracket, 0 is not included because of the asymptote y equals 0. Or 1 here is included to infinity. Okay. Oh, thank you, Zihin. X unequal -1. Okay, X unequal 1. X is real number. Okay, boleh juga lah. Betul. That's correct. Good. Okay, correct, Zinghen. Well done. Good. At least they are following my lesson. Okay, right, next. D. We have 8 minutes. Okay, I can go slowly now. Okay, this is a rational function, but we have a model sign here, meaning that the negative part of the curve is reflected in the x-axis. Okay, this is the negative part of the curve reflected in the x-axis. So notice that the curve here goes beyond y equal 1. Okay, goes beyond y equal 1. And the asymptote x equal 2, the asymptote y equal 1 only refer to this curve. Okay, so anybody would like to try down what is the domain? From the graph, what is the domain? For all x in R, but what happened at x equal 2? Yes, that's right, Chang Kwan. I think you are good in your interval. From negative infinity, it breaks at 2, or from 2 to infinity. Well done, Chang Kwan. Well done. Or you can write in set form, for all x in R, x cannot be 2. So choose which method you want. Okay. What about the range? Yes. The range. Okay. 0 to infinity. Good, Chan Kwan. You are following my lesson. Well done. Okay. Well done. Range is from 0 to infinity because we start here from 0. It's included till infinity. You look at the curve. From 0, it goes up here. Goes up till infinity. Similarly here, it goes up till infinity. Okay. You can look at the curve for the y values. Well done. Good. Next. Can you identify what is the domain? What is the range? This is ln x squared. It's not the basic function, ln x. Yes, anybody? Domain is very simple. Look at the asymptote. What is the asymptote here? What's the asymptote for this graph? X cannot be 0. The y-axis. So what is the domain for ln x squared? Okay, good, Chan Kwan. Negative infinity to 0 or from 0 to infinity. Well done. At least the rest, I think they know, but they are shy or it's too difficult to type. I understand, yeah? Because the symbol, okay, infinity is not given, okay, in the okay, thank you, Zihan. Well done. Negative infinity to 0. Okay, good. But then it's a round bracket. 0 is not included, yeah? 0 should be a round bracket there, Zihan. Should be a round bracket 0. Okay? Jap. Should be a round bracket 0. Okay, because x equals 0 is the asymptote. They will never touch x equals 0. Okay, the range? What is the range? Okay, I give you a clue. Sorry, Zihang, well done. Okay, it's good that we I also make some mistake too. Don't worry, we make mistake, but at least we realize the mistake now. Okay, what is the range? Okay, I already given you the red arrow. It comes from below negative infinity to infinity here. From below negative infinity to infinity. Remember, yeah, this curve is actually beyond our visible eyes. Okay, the portion of the graph is not shown in we cannot see with our visible eyes. And there's no dots to show that it's bounded. There's no dots, unshaded dots or shaded dots. So it's not bounded, okay? Okay, right. Next, the last one. Now this is simple. Wilma, is this for F, Wilma? Y equal R? I think so, yes. Yeah. Was it for, okay. Domain is for all x in R, yes. But the range for this function 1 plus EX. Okay, so I already shown to you. Okay, this is for range is minus infinity to infinity. Good. Are you sure? I think this is the previous question, I think. E ke apa ni? I'm not sure. Adam. Domain, yes. Domain is correct. I think it's for F. Yeah, domain is from negative infinity to infinity. That's right. The range, notice that we have asymptote here. Y equal 1. The curve will never touch. Okay, good, Wendy. Okay, well done, Wendy. At last, you saved the day. Okay, the range is from 1 to infinity. 1 is a round bracket because 1 is not included. Okay, well done, class. Okay, I'm so sorry. We are running out of time and I'm hurrying up and if you find that you need to rewatch again, please rewatch and try to understand. Okay, well done. No, it was for E. Oh, for E. Okay, well done, Velma. Yeah, that's right. Sorry, Velma. I think my internet is quite slow because the comment is coming up quite late. Anyway, students, you are superb. You're awesome. And today, I think the class is quite lively. I'm very happy. Okay. All of you have motivated me to do more lesson. Okay. That's all for today. And don't forget, okay, to subscribe my channel, Cikgu Zana channel. Remember, if you type Cikgu Zana, ramai tau. There's not only me. Rupanya, when I type Cikgu Zana, there's 3 Cikgu Zana, okay, that comes out from the YouTube. But my full name is...
Including our one Zainariah, right?
Yes, there's so many.
Junior.
My junior. There's so many Zana in the channel. Okay, but I'm Zainariah Abdullah. Okay, so make sure you have the correct YouTube link. Okay, right. Thank you. Hopefully you do well in your studies and make sure to get A, there's no A plus in STPM, but I hope you get A plus. Your marks is up A plus for your SEM 1 later on. And for the SEM 2 students, if you were to resit, hopefully you will improve your grade. Okay. I pass this to Cik Umaya.
Okay, so with God's grace, we have reached the end of today's session. Congratulations to those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the last digit code for the credit claim. So the digit is number 8. Okay, number 8. So all of you, please stop posting your comments for a while, and if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, not the red color. Okay, so and also activate the icon bell so that you will not miss the next session class. Then if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Okay, once completed, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. So, okay, link for the certificate and link to claim credit are already given in the chat box. Okay. So, please take note, the link will end half an hour after this live. So, make sure to use the EDD email only to log in. Incorrect email used will not be entertained. So if you haven't got one, please apply. The link to apply the email is also given in the checkbox. Okay. So if you wish to get more information on the online classes, go to www.academyyoutuber.com. So to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. Remember that the more classes you join, the more credit you can claim.
Yes.
Okay? So feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter too. Okay. I think that's all for now. See you in another session. Ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. Stay safe till we meet again next week. Same day, same time on Saturday at 5 p.m. Bye-bye.
Okay. Bye-bye. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.